Hello, today we will be continuing our coding evolution or genetic algorithm. Today we are going to work on the natural selection part and the S selection. Okay, now we have our project. Where we left, we were working on N selection. So we will be working on that. Currently, we were working on delta F. So let's take what we wanted, and so what we simply want is to make a below 25% or n is 0 to 1%, and if that is there, so we will be simply define delete low fit. Here what it will have is that it will have simply it will get a fit list and a gene list and the lowest one that we want, so a number between 0 and 1. So we will be putting rates. Now let's just put something here. If rates is bigger than 1, we will give out a value. If not value, let's do something else. If not rates under 1 and not rates under 0, it will be this, and let's wrap these in parentheses. Okay, now we have did the work with our value. Now let's make what we want. So we get our delta F. We also need delta F. We need a delta F and a gene list that we have. Okay, so we need LST2, which will be that we will sort that. So gene list and LST2 dot sort. Here what this simply is that it just gets that, and here LST 0. This is the one with the least number. So we just want to do something. Let me open up so I can show what I want to do. Okay, something happened. Let me okay, now it's displayed. Here what we want to do is that here we have a list. Let's say fitness 1, 2, 3. The range that this has is 3 minus 1 is equal to 2. Now what we want to do is to simply delete all numbers below that. So what we want to do is that we get the most. Let's say the most is m and the least is n. M times our, let's say, rates r plus n is what we are going to do. So let's do this. So if we say it is the below 33%, so m, which is 3, times 33 plus n, so let's say that will be 1/3 times third, which will be simply 1 and 1 plus our n, which is 1, which is 2. So everything below 2 will get deleted, which will be that. So let's code it. Okay, we have this and lst 2, that will be 1. No, -1. These are our what? Most, least, and most. Here what we will do is that we are simply going to code that, which will be most times rates plus least. This is our minimum fitness index. Now here for I in range what we will be going gene list len gene list, we will be making a variable here. So let's also add a variable tab, which we will call this check, which will be 0. For I in range len gene list here, if okay, if gene if range len gene list, that will be, what would that be? If gene list, what I'll check is below if that is under okay, here we are. We were going, if it is below that, what we will do is that we will be first doing that gene list dot okay, gene list from that check dot pop gene list dot what was it? How did you delete from lists? Let's just turn it to 0. Gene list check is equal to 0, and the same fit list check is equal to 0. Then nothing would happen. We would then, when we were exporting them into another list, it would be simply that. So after that, it will end the results and check is equal to check plus 1. Now, one thing that we haven't used is delta f, which I thought we would use, but we did not use. Now, here what this does is that this simply delete them, makes them 0, makes their fitness 0, and that it makes more sense because when you die, your fitness also becomes 0. You have no ability to survive and pass your genes anymore. So that is more right. Yes, that is more right. So here we will be coding it. That, so it's for, let's define export and we will have a gene list, and this gene list for we will have a gene list for I in range len gene list. Let's also add an variable check, which will be 0 range len gene list. Okay, here we are going to make another list, so tab, that will be export list, which will be a list. If not gene list dot gene list check is equal to 0, what we will do is that we will export list dot append gene list check. A lot of variables, which will work, I think. Oh, I forgot to return. And let's return our gene list. Here we also have to return export list. Here, this is the natural selection part. We have made these variables, which are going to be that. Now we will work with S selection. So class S selection, which will be just like that. This will get a bit more complicated because, let me come here and show it. What we are trying to do is that we have a list and we have DNA. So let's say this is tier 1, tier 2, tier 4, tier 5, tier 6, tier 8, and tier 10. All of this wants to offspring or mates with the tier 10, but the tier 10 can only work with ones 2 below or 2 over. So what this is that it tries to come here, it can't. This also tries, it controls Z. So what it does is that it comes here, it can't, it doesn't accept. It comes here, it doesn't accept. It comes here, it doesn't accept. It comes here, it is used. So 1 and 4 will have a DNA. Now let's delete these. Then what we have is 2 tries to go with 10. It can't. Then it tries to go with 8. It can't. Then it tries to go with 6, which 6 minus 2 is 4. It can't. It tries to go with this. 5 minus 2 is 3. When this happens, that there is simply no other thing for it to mate with, what we do is that we say this is someone that can't pass on genes, so that will get deleted. Then we work with 5. It can't. We work with 8. It can't. We work with 6. It can't. It can. Wait, 8 minus 2 is 7. So these 2 also. And then only remains 8 and 10, which they can. So what we have here is these. You can see that we have lost a lot of genes. We made from 1, 2, 3, 4, 2 times 3 is 6. From 7 genes, we made 3. So what we are going to do is that we do things that some of these have more children, like this. Ones with more tears will have more DNAs, offsprings. So this is the average of tears. So AVG of our tears over 2. We will round that up. It is not an actual simple, I am just trying to communicate that. We will round that up, and that will be how many that will have, and they will go through mutations. So let's go and code it. Let me. Okay, now what we need is a way to tier all of them. So we need tier genes it will tier the genes. Okay, I didn't define tier genes. We will have a gene list and a gene and a fit list. Here what this is that we are going to have a gene list and a fit list, as we said. So, and also we are going to have a delta. Okay, we need also we had something. What was that? Mathematics, absolute range calculation, range list. We also need a range list. Range list. Now here, it will base them on what that is. So the fit list, so we will have a for loop, and when we have a for loop, we need a check like always. So for I in range len gene list, that will be simply, now let's tiered genes. that will be what we'll be doing is that we will be doing based on the fit list. Now, because our code is something abstract, we need it to be self-expandable, not self-expandable like those factorial factors which use robots to make them more. We use for loops. So for I in range len gene list, or no, range list, what we will be doing is that we will be tuning them. So a for loop that will go by range list and checks if no. We will also need a check is squared, because that will be also that. So for I in range list, if range if gene list check is bigger than range list, what check square, we will check squared will be simply equal to check squared plus 1, and if else we will have a genes dot append what that will be simply check a square, that will be its tier. So let's separate these a bit, and then we will be resetting check squared. Check squared is equal to 0 again, and then after this whole maneuver of the second for loop is done, we will be making check equal to check plus 1. Now, this will be the fit list, not the gene list. Fit list. Let's come here and simply add S select I made a stupid mistake. S selection dot your genes. Now what we'll be doing is that let's make gene which will be hundred and 100. And okay, let's just run it. Yes, it works. So here we made this. What we want to do next is we will look at the diagram and see that they are good. So let's code in the define offspring rate, which will be parents 1 and parents 2. That will be the tiers of them. So parents 1 plus parents 2 over 4. The reason that I am going over 4 is that let me paint and let's delete this here. Now what we will be doing is that we will be getting the average. Let's say the average of the tier is T, or let's just work with A and B. A plus B over 2 is our X bar, because well that is the average and that is always we are going to have that. So that I think would be T bar. So T bar, and what we are going to do is that we are going to do this over 2 times 2. But what that will be is that 2 times 2 will be 4 and A plus B. That is what that will be. So let me come here. Okay, that is the reason that I am doing that. Over 4 and here round and it will be this, and I think that is right. And And okay, I hope you enjoyed this video and learned a lot from this video. And this is it. If you want to get more of my content, here is my channel, and there are some videos here which you can watch. They are pretty good videos. This is the part before this. This is the first part of this. And yes, that's all.